Hi, my name is David Garcia, and today I'm going to be talking about our organic chemistry lab, which is the experiment of simple distillation and fractional distillation. To introduce the topic, distillation is the combined process of heating a liquid until it boils and passes into its vapor state, followed by the condensation of that vapor into a liquid. In this experiment, the student performed simple and fractional distillation to separate ethanol and water in a mixed solution, comparing the two different methods of distillation. Before we even begin our experiment, we have to get our materials. This slide shows all the different materials we used during the experiment, but I'm just going to point out some very specific few that are very important. For example, the jacket condenser, which runs the water and distills the alcohol, the distilling column for the fractional distillation, the thermometer to keep recording of the temperatures, the glass beads, which are used in this distilling column to keep the theoretical plates going, the round bottom flask, which holds the solution, and the vacuum to allow the droplets to go into the graduated cylinder. Now that we have our materials ready, the student will set up the apparatuses shown right here. For example, on your right, you see the setup for the simple distillation, but on your left, you see the setup for the fractional distillation. But before we get into the comparison between the two, I'm going to talk a little bit more about distillation. The ability to separate two mixtures based on their difference in volatility is the basic idea behind distillation. When two mixtures mix, the more volatile liquid, in this case ethanol, will have a higher vapor pressure. The vapor will then condense back into its liquid form, separating the mixtures. As distillation is repeated on the distillate, the concentration of the more volatile substance becomes greater. On your right, you see simple distillation, which allows for only one cycle or theoretical plate to occur, but it's quicker. On the other hand, fractional distillation, as shown on the left, allows multiple theoretical plates to occur with the use of the glass beads, which increases the surface areas within the distilling column. This allows the vapor to condense on each individual glass bead, giving a pure concentration of ethanol after condensation into the distillate. The real only problem with this is that it takes longer than simple distillation just because the theoretical plates are multiple within the fractional distillation. Throughout the experiment, the student recorded the temperatures at every 0.5 milliliters for a total of 15 milliliters when distilling the alcohol. From the graphs, the student compared the results from simple and fractional distillation. In the graph, simple distillation is highlighted in blue, while fractional distillation is highlighted in red. Comparing the two, fractional distillation was efficiently better at separating ethanol from water. Fractional distillation had a better consistency, keeping the temperature around the boiling point for ethanol, around 77 to 78 Celsius. This means the condensation to form the distillate had a higher concentration of ethanol. Additionally, more volume of ethanol was collected in distillate in fractional distillation compared to simple distillation. Simple distillation roughly collected around 11 milliliters of ethanol, while fractional distillation was still collecting ethanol in the distillate around 15 milliliters. One thing to point out on the graph is during the fractional distillation, the student ended the experiment too early because the ethanol was still distilling from the water and didn't fully distill because there wasn't a spike, as shown here. There wasn't a spike for the ethanol to run out and water to be boiling. In the experiment, there were multiple areas where the student had the potential to do errors. The student could have ended the fractional distillation too soon, before fully collecting all the ethanol within the mixture and allowing it to evaporate, leaving only the water there and allowing the boiling point of water to be reached. Additionally, the air bubbles within the condenser could have also influenced it, as you can see right here, could also influence the amount of ethanol being collected in the distillate. Also, the flask not touching the heating mantle could have played a role in allowing the ethanol to be distilled from the water. And finally, the graduated cylinder hanging when collecting the distilled ethanol could have lost drops, in total losing some volume. In this experiment, the student separated ethanol from water through the methods of distillation. The student compared two different types of distillation, simple and fractional. While simple is quicker, fractional has a better efficiency in separating the mixtures. The student learned 2 new techniques and concepts to allow the separation of mixtures, and thus enhancing his chemistry background in the separation of mixtures. Thank you for your time, and that was the end of my experiment, and hopefully you enjoyed.